Welcome back everyone. So in this session I am going to solve the problem 2 sum. So there is a part 1, also a part 2 in this problem that are slightly different, but more or less it is the same. So I will explain the part 1. So let's understand the problem statement. So you are given an integer array nums, and you are also given another variable which is an integer, which is target. And what you are supposed to do is that I will try to explain it in an example. So suppose if the nums array is something like 2, 7, 11, 15 and the target given is 9. You have to find those two elements which add up to give you the target. So in this example, it is this element 2 and element 7 adds up together to give the target. And you are supposed to return the indices of these elements in any particular order, it doesn't matter. So, and it is ensured that there will be exactly one solution. So what we have to return is that we have to return, in this case we have to return the index 0 which corresponding to the element 2 and index 1 which corresponds to the element 7. So that's what we need to do. How can we do that? So one thing we can do is that using hash map we can solve this thing. So straight away let's go into the coding session, because writing the code itself will give you the clear explanation. So what I'm going to do here is that, okay, first of all let's write the class and method definition. Class solution, this is a method inside the class, define to sum. So what are the arguments of that method? One is nums, where it is a list of integer, and another integer is given which is named as target. And what is the return type? Return type is a list of integer. So what I am going to do is that I am going to obtain a hash map. Basically it's a dictionary hash map. So in this hash map I am going to store element and its respective index. So this way I am going to store there. And what I am going to find is that whenever I am iterating, if I have gone through an element, okay, I will also check whether the target minus the element at VR is already in the hash map or not. In that case, that index and this particular index at the current state both gives a return of our that's a solution of what we want. So I am going to enumerate for I comma num in enumerate nums. Now I am going to find the complement. Complement equals target minus num. So already we have seen num at the ith index. We want to see whether a complement, that is target minus num, is already we have seen in the past or not. If we have seen in the past, we need the access of that index, and comparing with the current index, that's what we need to return. So that we are going to check. If complement in hash map, so in that case we just need to return the indices of that complement that would be available in the hash map, because hash map how we are going to store things in hash map is like element and indices. So the element here is that complement which we found. So if it's present, we need to find the hash map of complement and the current index, that is I. This is what we need to return, and each time we need to update the hash map. So that would be like hash map of the existing number is updated with existing indices. So in the question statement it's already mentioned there exists exactly one solution. So at some point this will return those pairs of indices that's corresponding to the elements that add up to the target. So that's how we are going to do it. So what is the time complexity of the solution? So here we are just iterating through the given array only once. So the time complexity is order of n. What is the space complexity? We have used extra space for the hash map. So for that, time complexity becomes order of n. So that's how we are going to solve the part 1 of two-sum problem. Then what is part 2 of this two-sum problem? This is slightly different from part 1. So let's try to first understand the problem statement of the two-sum part 2. So two-sum part 2, what is the problem statement? Two-sum part 2. The problem statement is that in the previous sum it was 0 indexed array or the list. Here it is 1 index array. But similarly you are given a nums and you are also given a target. And one more information mentioned here is that it is sorted in a non-decreasing fashion. It's sorted array. And one more condition is that whatever you do, you should not use extra space. You should do it in a space complexity of order of 1. Here it was the previous problem, it was not sorted. So, and there was also no further demands of what should be the space complexity we should have. So we have used it using hash map, but here it is sorted. We should utilize that particular feature of this problem to solve this particular question. So how can we do that? We can do it using a two-pointer approach. So what we can do is that we can fix a left pointer at the beginning, and if we can fix a left pointer at the beginning, we can fix a right pointer at the end. Since this is sorted, we can always calculate like pick an element from here, pick an element from here, like add up. If the sum equal to the target, we just need to return these integers. If that sum is less than the target, we need to update this pointer to here. But if it's greater than the target, then we need to decrease this pointer to here. Like that we can do up to the left becomes lesser than right. So at some point, since this problem gives at least one solution, we are bound to get the answers or left or right. And one more thing to notice, whatever we are going to get left or right, we have to return left plus 1 and right plus 1, because in the question it's mentioned that it's a 1 index array. That's why. You will understand it much better when you try to code this thing. So let me make some space to write the code. So this is the class solution. This is the method inside the class. Define two-sum, and what are the arguments? Nums is given, which is a list of integer, and a target is given, which is also an integer. We are expect to return a list of integer, those two indices what we want to find. So let's fix the pointers. I am fixing the left pointer at the 0th, right pointer at the end, that is at length of nums minus 1, and I am going to move this pointers until and unless left becomes lesser than right. Here I am going to find the sum nums of left and nums of right when we got added. So if the sum equal to the target, if that happened at any stage, we just need to return left plus 1, right plus 1. This plus 1 because in the problem statement it is mentioned as it's a one based index array, that's why. But if elif, if it's sum less than the target, then the left should be upgraded, left plus equal to 1, else upgrade the right, it should be decreased. So at any point, at some point, this will definitely going to return what the problem statement demanded. So what is the time complexity? Here the time complexity is actually, if you see, this is the iteration part. So it is by left less than right. Basically the time complexity is n by 2, but we can omit this 2, it will be order of n. And space complexity, as the problem demanded, we have not used an extra space or anything. We have utilized the feature that it's already sorted and used the 2 pointers, and we have solved it in a complexity, space complexity of O1. With that, we are going to conclude the 2-sum part 1 and 2-sum part 2. Thank you for listening. Thank you for attention.